Alright, welcome back to the channel. Pleasure to have you here again. This is Pendumatics, your complete online school of mathematics, and all we do here is teach and talk mathematics. We break it down, making it as easy as possible and as simple as possible for you to understand. Alright, welcome back to the channel. We are looking at another aspect of surds. Alright, so in our last video we started looking at surds. In this video we're looking at mathematical operations with surds: addition, subtraction, and multiplication of surds. That's basically what this is all about. So if you're new to the channel, do well to subscribe to this channel. We have a lot of content that we make on mathematics, different topics, different questions we solve. We don't just solve questions here, we teach. Alright, so subscribe and make sure you turn on notifications, ring that bell so that you won't miss any of our content. Alright, you're welcome. Let's look at, we have some examples here that should help us understand how to add, subtract, and multiply surds. Alright, so as we go on, if you find the video helpful, don't forget, drop a like on the video, drop your thoughts in the comment as well. I love to read from you and know what you think. And then finally, share this video as far and as wide as you can share it. Alright, it will help people. So share it out as well. Right now, before I start solving it, there's something I want to just address. I showed it in the last video with certain surds, but just to take over this, I'll just consider the same way you look at algebra is the same way you look at surds. For instance, if you have 5a plus 2a, alright, most of us, most people don't have anything. Alright, 5a plus 2a, we really need that this is 10, right? Now, look at just the same way. I told you in the last video, if you have 5a, k here, b, c, okay, look at this root part or this surdic part as a letter. The same way you treat letters when you are solving algebra is the same way you should look at this. Alright, so something like this now, all you need to know, the same way this is 7a, this will be 7. Alright, so the same way here you add number, same way here you just add. Right, so just consider it as letters. If you have 5a times 6a, alright, in algebra you cannot add it. You cannot multiply it because, sorry, if you have 5a plus 6b, sorry, you cannot add these two because they are different terms. The same way in surds, if I have 5 root 2 plus 6 root 3, I can't add them because they are different terms. This is a root 2, this is a root 3. I cannot add these two surds. The same way I cannot add these two terms in algebra. So that same analogy or idea or knowledge you have about algebra, apply it to surds and you will not have mistakes and you will not have problems. Alright, so this will help you. Whenever you come across surds, don't let it confuse you. Alright, the same way you operate with letters, just think of it as these roots are replacing letters. So in a case like this, because they are the same root 2, you can add. Just like if you have numbers like letters like this. In a case like this, they are different roots, you can't add here. Just like you will not be able to add if these were letters. Alright, so just put that in mind. It's the same thing if this is subtraction, you can't subtract. If this is subtraction, definitely this will give you 3a, right? The same way, if this is subtraction, this will give you 3 root 2. Same way, just subtract the numbers. Alright, the multiplication has no issue. 5a times 6b, you can multiply. This will give you 5 times 6, 30. A times b, ab. You can multiply. The same thing with surds. 5 root 2 times 6 root 3. You can still multiply. Multiply this to 30 root, multiply this to 6. Alright, so just what I want to point out here, have that analogy. The same way you operate with letters, the same way you operate with surds, and you will not have issues. Alright, so this being said, solving this should not be an issue again for you. All right, so let's quickly do those. If you understood what I just explained there, then solving this should not be an issue for you. All right, so let's look at this. A, we have root 28 plus root 63. Now, to be able to solve this, remember, you can only add when the two surds have the same root. You can only add or subtract when the two surds have the same roots. So in a case like this, you have to put both of them in the same roots if you are going to add. So that means we express both of them as product of factors that have the same roots. That means that will be multiplying by roughly the same number. So what does this mean? I can express 28 as 4 times 7, and I'll express 68 as I think 9 times 7. Yes, 63 is 9 times 7. Let me have my calculator so that I can easily check all this. Alright, now this is what I was trying to tell you. You can see here that there is 7 and there is 7. So there must be similar roots if you are going to be able to add. I cannot come here and say maybe 21 times 3. That already 21, 3 and 4, 7. There's nothing similar. So in that case, we'll not be able to work. Alright. So 9 times 7 and 4 times 7 is a good way to go, because now there's 7 here. And remember, in the previous video, we said one of the factors must be a perfect square. One of the factors must be a perfect square. Alright. We are trying to simplify this and simplify this to be able to add. Alright. So I told you in that previous video, you can break this into root 4 times root 7 plus root 9 times root 7. If you've not watched the previous video on surds, please do well to watch it. Alright, now square root of 4 is 2 times root 7 plus square root of 9 is 3 times root 7. This will give me 2 root 7 plus 3 root 7. And in this case, just like I explained here, because they are both in root 7, I can add the whole number parts. So 2 plus 3 will give me 5 root 7. And that's the answer to this question. Alright, 5 root 7. So it's not difficult. Try to simplify them, but make sure you use factors that are common to both sides, so that you have a common root that you can add. If the roots are not common, you cannot add them or subtract them. Alright, and remember that one of the factors must be a perfect square so that you can bring out the square root. I hope that's clear. So B, we have root 128 minus root 8. Now again, we'll break them down. We already know that we can express 8 as 4 times 2. Alright, 4 times 2. And this is the only way to express 8, whereby one of the factors is a perfect square. Alright, so we also have to express 128 as a factor of 2. So that's 64 times 2. Now you can see that we have root 2 here, root 2 here. So there's something common between both sides. And also 64 is a perfect square, 4 is a perfect square. So we can break this into square root of 64 times square root of 2 minus square root of 4 times square root of 2. Square root of 64 is 8 root 2. I'm just going to multiply it, minus square root of 4 is 2 root 2. And this will give me 6 root 2. 8 minus 2 is 6. Alright, 10 root 2. Alright, so not difficult at all. Just simplify it, break it down into two factors. The same factor here must be here. There must be something in common between them, and the other factor should be a perfect square, so that you can bring out the square root like this. Okay, I hope that's clear. If you have questions, feel free to put it down in the comments.